Welcome to another challenge of Shastra. Minimum barriers to clear path. The problem statement is as follow. You are given a 2D integer array of size m into n. Each cell has one of the two values. Here 0 represents an open path and 1 represents a barrier. From one cell you can either move up, down, left or right through open paths. We need to return the minimum number of barriers to clear a path from top left corner to the bottom right in the array. The input format is as follows. The first line of input contains an integer t denoting the number of test cases, and in each test case contains two space separated integers m and n representing the size of 2D grid. The constraint is as follows. The value of m and n ranges from 1 to 10 to the power 5 and m cross n is from 2 to 10 to the power 5. The element inside the array is either 0 or 1. So as we mentioned earlier, that 0 represents the open path and 1 represents the barrier. And there is also one special thing, that the first element and the last element, that is the bottom corner, is 0. The output format should be an integer that would contain the number of barriers to clear. For example, let us consider this. Here we have two test cases in this while. Our m and n are 3 and 3 respectively. So this is our grid. We start from here 0 and we need to reach here. We need to decide which path to take to minimize the number of barriers. The barriers are represented by 1 here. So basically these ones are barriers. Array representation of the grid. Here these are the indexes, and we will be starting from 0 comma 0 and moving towards 2 comma 2 while minimizing the number of barriers in our path. So what we can do, if we are at 0 comma 0, we can either move left, right, up or down. So we need to keep a track what is the cost of moving towards a cell. Like if I move towards down, my cost increase by 1, and if I go further like right, my cost goes from 1 to 2, and if I go right, the cost remain as it is 2, and this is 2. So the final cost would be 2, and if I follow this path 0 1 1 1, that would be 3. My final cost would be 3. So we need to minimize the cost. So for that we need to make a grid which will keep a track of what is the cost of moving towards a cell. So I have already made a grid, and we will be using a BFS approach. So this is the queue. This grid is initialized with infinity, and the very first element is 0, the initial cost, and here this represents the x and y coordinates, and the last number represents the what's the value. Okay, so we pop this element out from the queue, and from this cell, okay, 0 comma 0, we check for all the four directions. So we cannot move towards up, we cannot move towards left as they are not in the bound of the array. So we move downwards. So when we move downwards like this, okay, so we check what is the costing for moving towards this cell. Like we need to update the value as well. So when we move downward, that would be 0 0 plus 1. Here 0 plus 1, that would be 1, and since 1 is less than infinity, okay, that's the reason I have initialized with infinity. So 1 is less than infinity. So what we can do is we need to just put this element inside our queue. Like we put this element inside our queue, the updated element along with the indexes. So that would be 1 comma 0 comma 1. Okay, and our one more direction is remaining, so we can go from here to right, and again we do the same stuff. So what is the costing? That would be the same, that is the initial cost is 0, and the 0 plus 1 would be 1, and 1 is less than infinity. So again we update this and we put this inside the queue. So our queue would look like this. Okay, and this is the cost matrix that we made. And what we'll do is now we pop again one more element. Now we have pop 1 comma 0. Okay, so this is 1 comma 0. So for this 1 comma 0, again we check for all the directions. If we move upwards, okay, if we move upward, the costing would be 1. Here the current cell that we pop out, so costing would be 1 plus 0. Okay, 1 plus 0, that would be 1. And since 1 is not less than 0, so we won't be updating a value and we won't be adding towards it the cube. Okay, so one direction is done. Now let's move towards right and down. So in the similar way, the costing will go from like 1 plus 1, that would be 2, and 2 is less than infinity, so we can update it and we will put it inside the cube. And same goes for this, like 1 and 1 plus 1, like this one. And we add both of them, and 2 is less than infinity, so we update the value 2 and we put this cell inside our queue. So further our queue would look like this. And now we pop one more element, so let's just pop this element out. This is 0 comma 1. This is this element. Okay, now for this cell, again we check for all the four direction. We cannot move up, so we check for left direction. So as I have told you earlier, like 1 plus 0, that would be 1, and 1 is not less than 0, so we won't be updating and you won't be adding it towards the queue. Okay, so this remain as it is. And for next three direction, sorry, next two direction. Okay, so for this two value, so that would be the current value is 1. Okay, so 1 plus 1 would be 2. 2 and 2 is not less than 2, so we won't be updating the value and we won't be adding it towards the queue. Now let's check for one more for this. So here the value will be updated from infinity to 2, as 1 plus 1 is 2 and 2 is less than infinity, so we update the value and put it in the queue. So I hope so you get the approach, what's the approach behind this. And in the same way we just pop this element out, 2 comma 0, we update the value, we check for all the directions, and if the value is less, then we update the value and put it inside the queue. So here we get the 3, and at last our answer would look like this. So what we need to return is this last number. Okay, that would be the answer. It would be the minimum cost that we need. So this is the solution. uh, Here this is the main function. T is the number of test cases, and m and n is the dimension of the grid, and this is the actual maze. Okay, so we are reading the maze and we are now passing the input towards the function minimum barriers to clear the path. So here I have made a directions array or directions list, and inside it I have four directions, like up, down, left and right. These are the four directions in which we can move. We cannot move in diagonal, so we have four directions. And this is the grid that what I was talking about. Like we initialize with the float infinity, and you know the reason of behind initializing with float infinity, as we need to compare it. And to do BFS we use Q, so we have initialized Q with the very first index and 0. Okay, and we also made the very first element 0 inside our cost array. Okay, so min cleared is our cost array. Now till the queue exists, okay, so we pop first element, and for all the directions, as I said earlier, for all the directions we check. So from the current cell we update the direction. These are the new directions. Okay, and we check whether these new directions are inside the bound of the array or not. And if they are inside the bound of the array, we check what is the costing of moving towards the cell. And if the costing is less, then we simply update the value and append the index as well as the new cost. So at last, after the loop ends, we have our answer in the very last cell. Okay, and I forgot to talk about this case. Like at times you won't be updating the value. Like here we directly have the path. So there is no need, so the answer is 0. And let's just run this code. As you can see, now let's try to submit it. Our all the test cases are passed. Thank you for watching.